For this week in the wiring diagrams assignment, you're going to go back to Trane RTU, which you probably already have because you found this video. And the video will be right in here underneath the quiz that you just completed from last week. So this quiz will be Trane RTU quiz number 2. And there's a couple more documents that I've added here that will be things you need to look at in order to complete the quiz. The first thing here is the Trane precedent 2-stage wiring diagram. And you'll see it's a lot like the diagram we looked at last week. This one is for 7.5 to 10 ton. The reason I use this diagram is because it does have the second compressor here, 2-stage cooling, but what I wanted to cover was the Voyager 27.5 to 50 ton commercial units. These are much bigger rooftop units than the 3 to 10 ton what we looked at last week. And there's a lot of information in this book here. This is a 156-page IOM for the Voyager commercial. It is actually a fairly new one. It's from February of this year. So I'll show you some things in here that you'll need to look for in order to complete the quiz. But going back to the wiring diagram, because I could not actually find a wiring diagram for a 27.5 to 50 ton, but if you look here, you'll see it's still, this is the control, this is the same control board, the Reliatel control board that is used on the 27.5 to 50 ton unit. Same board as you're seeing right here. This RTRM board is the Reliatel board. So there's your compressor 1 contactor, compressor 2 contactor. Here's a reheat valve. Reheat, if you're using dehumidification, you use a reheat coil. It's actually putting a condenser coil in the airstream downstream of the cooling coil so that it reheats the air. That's a way of dehumidifying. If you have a dehumidifier in your basement, you'll notice that the air draws through the evaporator, then it goes right through the condenser so that it really doesn't change the temperature of the air. It just dehumidifies the air. But that's what the reheat valve there is for. This is the RTRM board, which is the main control board, the Reliatel board. There's your ignition module for gas heat. Here is the RTOM board, and RTO is the options board. And you'll see it starts here, but it also continues on the next page. Here are more inputs. Here's a frost stat, a clogged filter switch, a fan proving switch. Those are all tied to the RTOM board. Here is the ECA, which is the economizer actuator, and you'll see that it has the outside air humidity sensor, the return air humidity sensor, return air temperature, mixed air temperature. Also, you can put a remote minimum position potentiometer to this ECA board. Some of the things you'll need to know for the quiz, here's descriptions. And when you look at this, it has not only the letters that, like CC1 is the compressor contactor for compressor number 1, but here it says line 101. So when you look down the left-hand margin here, if you want to find compressor contactor 1, you would go to line 101 right here, and you would follow across, and there it is. So that table right here is going to be kind of important when you're doing the quiz. So there's 2 pages of a Reliatel 2-stage cooling wiring diagram. Here is the IOM, and on this IOM, I want you to look at some very specific things. Here's the table of contents, and one thing about this, if you open this in a PDF file, I assume you have a Adobe Player software. It's free. When you click on something like right here where it says general information, it will take you to that page. So there's some general information about the unit, the nomenclatures, the breakdown of the part number. One thing I put on the quiz that I wanted to show you just to make sure you knew where to find it. Right here in the introduction, you'll see where it talks about an overview of the manual, and it says this booklet describes the proper installation, startup, and operation and maintenance procedures for the TC blank TE or the YC, and it lists them as CV for constant volume, VAV for variable air volume, and SZVAV for single zone, and they have what's called single zone variable air volume. So that's kind of confusing because a VAV system is not single zone. You have multiple VAV boxes connected to a rooftop unit that's a VAV system, but they're saying this is a single zone VAV, which means that it's still like the constant volume, only has one thermostat, only controls one zone, but they actually do vary the air volume in the SZVAV. Kind of confusing, but you'll see that referred to in here as SZVAV. That does not mean that it has VAV boxes. That just means that it acts as a single zone unit like the constant volume unit, but it does vary the airflow like a VAV system would. But a VAV system, or the standard VAV, which they reference in this manual, is the type that single package rooftop unit connected to multiple VAV boxes, that type of system. So one of the things you'll see here on page 24 is the static track, and the static track is a way of measuring building pressure, and in this case, and I'll show you on the next page, it measures the volume of outside air that the unit is bringing in. But static track, if you ever see on the side of a rooftop unit where it has a bracket and it has this red, looks like something like a bird feeder thing, I guess, and there's a tube connected to it. That's an atmospheric pressure outdoor sensor. It is wind canceling, so it can be sitting on top of the rooftop unit, and you can have wind, and it does not affect the pressure going to the transducers, which on the page, next page here, page 25, you'll see here is the space pressure transducer right here, and this is the velocity, where it says from velocity ring. This transducer here is actually for the volume of outside air, but you'll see that it says it has a calibration solenoid, and this diagram here shows the transducer. It has a high port and a low port, and that's this part right here. So the high port is open to atmosphere, so I paused the video just to make sure that I had this straight before I went any further. Here is the solenoid. It has a common, normally open, normally closed. When it's de-energized, it's open from common to normally open, and where you see the high port for the space pressure, this is the high port right here. Excuse me, this is the normally open port of the solenoid valve. This would be this normally open port here is where you would connect your space pressure, and then this would be the outdoor, or where it shows outdoor sensor. That would go to the other side of the transducer. The purpose of the solenoid valve is to calibrate the transducer, and it does that automatically on a regular basis without you having to do anything. What it does, it energizes a solenoid valve, and that connects the low to the high, because when you energize a solenoid valve, the port from high goes to normally closed. This normally open port closes, the normally closed port opens, so it hooks or puts the high and low ports together, and it looks for a zero reading, or that's when it zeroes itself. So the calibration, every time the solenoid valve energizes, it calibrates the transducer to zero, and then it goes back to reading so that it can tell what the actual building pressure is. As we scroll down a little bit, here is some information about the electrical. Here's the RTRM board. Here's your thermostat connection, whether you use a zone sensor or a conventional thermostat. Here it shows the RTAM board, and you'll see here that the RTAM board has a cooling supply air cooling set point. That is a air handler module. As we scroll down, I want to show you a couple of the other option boards. Here's the RTAM. The RTAM is an air handler module. This is for the standard with the traditional VAV. So on this traditional VAV controller, you would have static pressure set point. This is not building static, this is duct static pressure. It's adjustable from 0 to 2.5 inch, or maybe a little over 2.5 inch there. But there's your supply air heating set point, supply air cooling set point, morning warm up. So if you have this RTAM board, has all these settings or set points, that would be for the traditional VAV. The RTRM is the ReliaTel board. It's the one that you saw from last week. The ECA is the economizer actuator. Here is the ventilation module. This one has the space pressure set point. And here is the RTOM, which is the options module. Here is the RTDM, which was for dehumidification. And I think we looked at the reheat valve on the wiring diagram. You would use the RTDM, the dehumidification module, if you had that reheat valve, and it kind of talks about that right here. So for your homework, or excuse me, for your quiz assignment, take a look at the wiring diagram, which was this right here. Take a look at the Voyager 25 or 27.5 to 50 ton handout. These two documents right here. Here's the quiz. You will find the answers. I don't want to give everything away, but you should take a look at these. I want you to take a little time, get familiar with these IOMs, because someday you're going to work on a Trane rooftop unit if you haven't already, and you'll find that these IOMs and wiring diagrams, once you become familiar with them, it really makes understanding and troubleshooting the equipment a lot easier.